Hello everyone, I'm Lawrence from XtraP. Welcome to Module 3, Starknet Architecture. We're going to be looking at Layer 2 chains, Starknet components, and interactions between Layer 1 and Layer 2. As always, these notes are available at cairo.xtrap.io. So let's start thinking about what is a Layer 2. Well, a Layer 2 chain allows us to move transaction processing away from the Layer 1, which results in better scalability and cheaper transactions. Now, we still need a connection to the Layer 1, and what we do is we provide updates of the Layer 2 state, the state transitions, to the Layer 1. And by adding these to the Layer 1, we are increasing the security of the Layer 2 protocol. Now, in the Ethereum ecosystem, the way that this type of technology has been introduced has been via what are called rollups. And these have been very successful, and there are two types of them: validity rollups or ZK rollups and optimistic rollups. And Starknet uses validity rollups. There's a couple of links there to give you an overview of Starknet. There's some documentation, and it is a very typical Layer 2. It uses validity rollups and is connected to the Ethereum mainnet, the Layer 1, and relies on that for security. It is a public chain. It is permissionless and partly decentralized. I say that because of one of the components of Starknet, the sequencer, which at the moment is centralized, but is moving towards being decentralized. Now, as a Layer 2, it offers us the usual benefits: high throughput and low transaction fees. And there are already a number of applications available on Starknet. You can see here we've got wallets, tools, dev tools, various services, lots of DeFi, entertainment, games, many applications already available there. If you want to find out more, there's a link there to a list that lists them all out. Okay, so let's look at it in a little more detail by taking a look at the components. So when a transaction is introduced into Starknet, it will be sent to the sequencer. And the sequencer really plays a crucial role. And it is responsible for collecting transactions and doing a lot of the coordination within Starknet. And it will take the transactions that it receives from the applications, and it will send those to be executed in the Cairo VM. And the result of that is an execution trace. So it will receive back an execution trace, and this trace is a very detailed description of the execution of the contract, of the transaction within the contract. And it sends that trace to a prover, the shared prover. And it is the shared prover's job to take that trace and to create a zero-knowledge proof, which is there to prove that that execution has happened correctly. Now, the sequencer will then take that proof. It will take the state difference that is created by the transactions, and it will batch these together, and there will be batching of the state differences of the data that is in the transactions, and there's aggregation of the proofs. The end result of that is it wants to send these to the Layer 1. So the Layer 1 needs to know the state differences. It needs to know the data from the transactions because of a concept called data availability, so that someone on the Ethereum Layer 1 should be able to reconstruct the state of the Layer 2. And then also we're sending the proofs, the validity proof, to the Layer 1. And this is sent to a special contract, a verifier contract, which is able to verify that proof and to do that succinctly. And what that proof tells us is that the transactions that have been executed and have produced a state transition have been executed correctly. The other point you see on here is the full node, because the Starknet is a blockchain. It has nodes, it produces blocks, and the full node is there. It will receive blocks and it will be able to update its own state. The other point you see here, this dotted line, the escape hatch, this is because of centralization fears, because it would be possible that the sequencer could withhold or ignore transactions. And for example, if someone wished to withdraw funds from the layer 2 to the layer 1, the sequencer could prevent this just by ignoring that transaction. And so the idea of the escape hatch is to provide a means for someone to force a transaction through, to force a transaction to be recognized on the layer 1 if needed. So there's details here of those items. As I say, the sequencer, very crucial. It has a pivotal role. It is there to do a lot of coordination. And at the moment, it is centralized, but hopefully in the future it will be decentralized. We will have the possibility of multiple sequencers. Okay. Now, the one aspect I haven't mentioned so far is the Starknet operating system. And this manages the updates to the state of the system. And this is particularly relevant to what we are going to be looking at, because Cairo, if we look at Cairo programs, so not Cairo contracts, but Cairo programs, they are stateless. And so when we move to Cairo contracts, we need to have state being held. We want state to be persisted over time. And this is what the Starknet operating system provides us with. So it allows Cairo contracts to have state, to have storage. Okay. And so the Starknet state, if you think of that as a whole, it consists of all of the code of all of the contracts within Starknet and all of the storage of those contracts. Now, moving to the layer 1, the Starknet layer 1 core contract is a special contract on Ethereum, on the layer 1, which is there to give commitment to the state of the layer 2. And it can keep other details as well, such as the latest version of the operating system of Starknet, etc. And this is there to provide security for the layer 2. By having the details of the layer 2 and the behavior of the layer 2 on the layer 1, we are providing security for the layer 2. It also allows us to have interaction between the layer 2 and the layer 1. So in addition to the normal transactions that we have, these proofs that are being sent that show that transactions are happening correctly on layer 2, we also have the ability for the layer 2 and the layer 1 to interact and for contracts to effectively speak to each other. I've already spoken about the full nodes, so they are there, they will receive blocks and they can update their own state. So I mentioned that there's this possibility of layer 1 to layer 2 communication. I've got further details there in the Cairo book. And there are built-in functions to allow this to happen. And there is a contract, the Starknet messaging contract, deployed on the layer 1, which will handle the layer 1 side. So if we start by looking at the way that the layer 2 can interact with the layer 1, of course we have the normal flow, as I've said, where we have proofs being provided and sent to the layer 1. But in addition to that, we are able to call contracts on Ethereum from our layer 2. And this uses the syscalls package. And the details that you would need to provide to do that are details of the recipient contract on the layer 1, and then the actual message, the data payload that you want to pass to the layer 1. And these details are then part of the layer 2 block that is produced. and the sequencer is involved in sending the details of this to the Starknet contract on the layer 1. And once this block is verified on the layer 1, once we're happy that this block is correct, then those payloads can be applied to contracts on the layer 1. If we move now to looking at the possibility of messaging in the other direction, from the layer 1 to the layer 2, what we can do is to call the Starknet messaging contract and call a particular function in that, the send message to L2 function. And the Starknet sequencer is monitoring the logs of this contract. So it will see when someone is calling this particular function. And so what it can do is then prepare a transaction that includes that message that that is wanted to be sent from the layer 1 to the layer 2. And on the Starknet side, the function that wants to receive this message must show that they are able to do that. And so for that, the function that is going to receive this message from the layer 1 will be annotated with a special attribute, which is shown there, the hash, the layer 1 handler attribute. Okay, so that is some details of the architecture of Starknet. That is the end of Module 3, and I look forward to speaking to you on Module 4. Thank you, everyone.